Is that right? Yep, cool. So gRPC, I've been doing, okay, honestly, I haven't spent too much time on it because I was busy a lot of different things and family too. Yeah, a bit about me. I'm coming from China, that's 15 years ago. I had a talk about 7 or 8 years ago on a different topic. That was pretty awkward because my English wasn't that good. I wasn't able to actually convey the message in a proper way. Hopefully tonight is not going to be catastrophic failing or kind of thing. If I'm bad, please just be nice to me. Yes, I've always been doing the .NET development. I think I'm brave enough to say that I've got about 20 years. That was since .NET 1.1, .NET 1.1. And along the journey, I tapped into all sorts of different other stuff, including things like web, or a little bit backend, cloud, and other stuff. I've always been in Adelaide. I have 3 children, have a family here, so kind of I can say I'm a local people here in Adelaide. Before I start, just do a bit survey. Let's see, have you used gRPC before? If you heard about it, hands up, please. Yeah, I would imagine most of us already heard about it. If you've been experimented already? No? Not even one? I would say none of us are in the production. So this is why we're here for. And I have a different script when I prepare. I'll say, oh, if you have it in production already, you know everything about gRPC, what's the point to come here? Have you know how old the gRPC is? Hands up if you think it's 2 years old. No? Hands up saying it's 5 years old. Okay, a couple. What about 8 years? So you guys have been researching before, right? Yeah. The answer is 8 years. So it was a, sorry, it was, I think, first published in February 2015, which is about 8 years ago. The gRPC itself has a different component to it. It's called protobuf. But gRPC doesn't need to have protobuf because protobuf is just an encoding kind of technology alongside with gRPC. So you can use a different encoding, a deserialization thingy along with the gRPC, or you can, if you use protobuf itself, you don't have to use gRPC. You can also use for different purpose. So, yeah. A bit of agenda. Of course, we're going to introduce a little bit of gRPC. I'm trying to do a lot of things, things like having a sample project and having some Python client, having some web client, doing a bit JSON transcoding. Hopefully we can cover most of them. If we can't, that's okay. I guess we can always learn from YouTube. The idea of doing this topic, doing this talk is, I guess it's just to let everyone know there's a thing there. If by any chance you have a project that you're going to do the communications between, either it's between server to service or service to client to device, you would think, you would have an idea that this is something I can use, this is something I can consider to use. By the way, when you're not, of course, in most cases you would use RESTful services. I mean, almost all of us actually having the experience write a little bit of RESTful services. But I know that a few of you guys already been trying a different thing called GraphQL. You've been using GraphQL. Hands up if you're using GraphQL. There's a couple. That's great. Yeah. So I'm not here to say, or if you're using GraphQL, you should use gRPC, because you can use both of them for the same purpose, but there's always a case, there's a better kind of justification to use one or the other. So gRPC, I don't know, some people say G stands for Google, because it's first developed in Google and Google released that as one of their products. But someone say G actually doesn't stand for Google. I don't know. I didn't search for that. Maybe something else. But I guess that doesn't matter, as long as it works for us. So it's I guess a gRPC is come out from the internal kind of product from Google called Stubby. That was being around for many, many years, because Google thinks RESTful services is not good enough for them, and they want something high performing. They want something that is actually works better for them, I guess, for their microservices kind of architecture in a services environment. But publicly, if you're interacting with the services with Google, most likely we will still interacting with the JSON services, which is RESTful services. Sorry. So a protobuf is a different thing. It's started 2001 in open source in 2008. I guess protobuf is kind of older than gRPC. Let's just. Okay, I'm going to create a gRPC service project. We're going to start from there. So that's just not talking too much talk. I'm really not a good talk. So let's do this. I guess we can do Visual Studio. Another way I'm going to do cheating too, because I'm going to reference to the solutions I already have. Okay, cool. So I'm going to create a new project. Of course, Visual Studio has the built-in template for gRPC. So let's start like that, or call it. Let's just place in a folder on it. Just call it. Will this be too small, or is it just enough? You good? Yeah. Make sure choose the right thing. No Docker. No top level statement. So out of way, we have a project, and in the project, it gives us some kind of a basic thing to start with. The first thing you notice is it's a dependency injection here to 8 gRPC, and there's a map gRPC services. So there's two things that get us going, and that's actually coming from a package called gRPC ASP.NET Core. And of this package are actually come from, if I do a build, it should actually bring the package in. Under this package, there's 3 different things. I don't know if you can see it. I lost my mouse. That's okay. There's a Google protobuf. That's it's the thing that's in doing the serialization, deserialization, or code transcoding, or whatever you want to say. Well, the other things we have is the Google tools. The tools mostly just enable us being able to compiling a proto file into a C# file, in which we're going to talk about later. There's also client factory, what we actually needed to do is to enable this is coming from actually that's the code actually have us to run the server code. Sorry, yep. So let's have a look at the services here. You see it's coming up, give us the greet.proto files. That's the service definitions, or I usually call it specification of the services. And with that, it will give us, generate the file like this, generate a C# services file like this, which is going to place under the, it's actually get placed under the code generation under the protos. There's 2 different files here. The service space they're giving us is what we can get to use to spin up our server code. And it has the virtual method here. It shows exception by default because we didn't override it. So go back to the actual services. All we need to do to have the service running, all we need to do is just override the services, and we have the contract, have everything ready. We have the request, and we should be able to run it straight away. I'll click that button. And the thing this one is the logging that coming out from the by default by the gRPC, or actually by the ASP.NET Web. And there you go. We should have. Where's our web? We should be able to access this by opening this one. That it's actually coming out from the programs. There's a map get here that's coming out from here. So it actually tells us we can't actually interacting with gRPC from the browser because by default, a gRPC hasn't got that capability to interacting from the browser straight away. So I'll show you later on how to enable such a thing, but for now, let's just try to call it with Postman. So we got the address here. Okay. There's nothing here, let's just create. So just trying to make a call here with the gRPC. How do I new a gRPC once? Okay, there you go. gRPC request, that's the JSON ones. So you can see that if we put the address here, but by the way, by default, gRPC needs HTTP2 and it needs HTTPS as a TLS authentication. So for the security kind of point of view, we can enable the plain HTTP. But I guess there's no point in these days. Certificates can be either get by free or anything. So to get the contract, we would usually just select the protocol, because by default we don't know how to talk to the gRPC services, because the data get transmitted through the gRPC services actually serialized as a binary format. Where in the binary format, it usually has a number with corresponding data in it. It's as simple as that. So you've got number at number slot 1, you have maybe an integer value. At number slot 2, you probably going to have some, let's say, a string. Number slot 3, you have a data or some date time or those kind of value in there. So there's no way we would know which one is which. So by kind of interacting with gRPC service, the both server side and the client side will need to have a definition to be able to decoding or to be able to deserialize that into a proper object that is actually human readable. So Postman is the same. So over here, we have to choose a protocol. Once we choose that, the Postman knows what to do. So hopefully we can choose a method. The method is coming up from our protocol that is over here. We have a greeter service. The service has a method called say hello, take the hello request, returns a hello reply. This is a service contract or service definition. This one is our data definitions. So come back to the Postman. The Postman, by looking at a protocol, understand we have a service called greeter and have a method called say hello. So in doing this, I guess we can invoke. It's hello nothing because we didn't got any data. I guess we can do a name. If we say hello cool man, that should come back hello cool man. Yeah, so as easy as that. So you create a new project, you define, I guess you can change the service definition or create a new service definition. You define that, the code automatically generates for you, and then you can start implement new service, and then you can interact it straight away. The Visual Studio, the MS project the project system is smart enough to work it out. The code generations, because we have in the project file, you have the protobuf item that include the files and we say generate the services or the server code for me. The code generation actually have a few different things. We can actually generate client code, or we can do both here. So once we change, let's say we change the both, and if we close that, and we have the build flag, we can actually go back to the generated code. If we're inspecting this, it's actually generate a client code here straight away for you. So yeah, I think I'm still in the Postman. I guess I'll do another cool thing. I think this is relatively new feature called gRPC reflection services. It was always there, but it wasn't actually in .NET. So what it's doing is actually it's publish the services, additional services on the top of existing gRPC services so that you can actually do service discovery without taking or giving need to have that profile. Similar to what you usually have with the Swaggle or Open API kind of arrangement over there. Let me think. I believe to enable such a thing, we will need to introduce a new gate called gRPC reflections. gRPC estimate call server reflection. Okay, and then in the program file, see, I need to cheat because I can't remember everything. Where's my cheating project here? So we're going to so we need to add the service gRPC reflection. That's one thing. We also should be able to map the gRPC reflection services. So obviously here, this one say only do that in development environment. Things we just do in demo, we don't care. Let's just do that here. Yep, that should be it. So if I say I'm gonna map the reflection service, just prove that it works. Let's create a different service here. Say hello again. Hello request returns. So we can save that, build that, and we're going to just override it. There you go. It's there already. So we're going to do a similar thing, or we can have something like this. We can do the similar thing, I guess. Or we can have it a bit wait, actually. Delay. Wait for 2 seconds. That's 200 milliseconds. And we can return our reply straight away. Oof. It's quite small, isn't it? Message equals hello again. always want to do this. I'm used to it. So after that, if we run the services, what? If we run this, go back to a Postman, there's no say hello to you, but if we say change the service definition, we can do use server reflection. So once we did that, we should be able to say hello again. And then go back to here. If we invoke that, it's going to take 2 seconds. That's what you do. Say hello again, cool, man. So this is one of the cool things that I added recently, which I'm quite excited about. I think this is something that will be make it into kind of next level of the service discovery between the services, or if we want to give it to customers, they say, oh, here's a URL, do your own service discovery and generate your own code. We don't care. It will work, of course. Be honest to you, I haven't touched gRPC for almost 2 years. So this is completely new, something that I'm quite excited about, and something that I want to actually share. Let's go back to what we do next. I guess the next thing we do is let's create a .NET client. Let's call it and let's see how we go. So I'm going to create a new just the console app. I'm trying to get the good naming. I just do client. We know this is a C# client. C# client. Okay, don't use that. There you go. I'm going to do hello world. I'm going to keep hello world. That's okay. So because we generate the both, that means I can kind of reference the server client. I know, but it's probably not a good practice. What should we do? Should we just reference the server, or should we generate an additional one? Let's do an additional one, because that's what I would usually do, because I don't want to actually having a client reference the server assembly. Let's just generate the client itself inside the assembly itself. So what we need to do is actually, we need to have reference to the protocol, and we need to have capability to be able to change that to server. Have a capability to be able to generate a code as it builds. So I'm going to cheat again by copy and paste, because I always do that. So this is the piece of a code I can So this is that link, common code, link from one project from the other project. But I guess I need to get the folder right, because we are in a different kind of folder. There you go. It's not happy. So we got the client and we got the web. Under the web, we got the Plotus, which is something like that. It's not even showing. Let's just try the hard way. Let's see what went wrong. 8. Existing item. Go to the web project. Choose the profile. I guess it's not. Choose the everything. Go to that one. Add this link. So what went wrong? Photos include. That's right. I guess this done it. Ooh. I don't know what's going on. Let's just forget about this. And let's just use our old ways to do it. Oops. I like to have it under. I like to have it under photos. The Greek dot photos. It's been funny.
So what do you expect? If you remove all the stuff you've added and re-add the link, because then it won't do the remove include.
If I remove,
Go back to when you had nothing in there except your first property group, and then re-add your link to your profile.
oh, okay, just us, okay, well, let's do that. Existing items. Oh, I think this we got the file structures not quite right. Let's go. It's all messed up. Let's. I guess we can fix it. By moving both of these out into this guy. And let's open it up again. And let's just do this thing again. Hopefully it appears. No. Give up. Just remove this one. Let's just add the definition file. The proto file. And the right photo, choose the right file. Let's add this link. There you go. Behaving like the right thingy. Let's just place that on the same kind of photo structure. Yeah, there you go. It's behaving now. It's none at the moment. That's okay, but because we need to add a new get reference to enable the code generation. I believe that is. There's few things. We need the Google profile, we need the client, and we need tools. We need 3 of those things. Let's just do a separate icon group. We don't need the JSON transcoding yet, so we're going to talk about it later on. So we need to change that to protofiles to enable the code generation. Protobuf, sorry. I'm going to type it right. No. Lowercase. 1F. There you go. All right. So after that, we should have the client code. We should be able to call it by having a piece of code like this. There you go. And to be able to do that, we need the channel. Or just having a server address. And we'll have the channel. The channel will be Yep, so to be able to call the gRPC services, all we need to do is create a channel and create the client object and invoke the method. And then we should be able to get the response straight away from that object, from the channel. In talking about channel, when the gRPC client, by default, interacting with the server or services, by default, it's HTTP2 only. And also, by default, it's create one single channel, and all the communications is going through that one single channel. So in the whole of the application lifetime, if you're lucky enough, if you're a good network, you should be able to just create one channel, and everything is going through the same channel. Similar like what we're doing with the socket communication or all other kinds of communication. All the heavy lifting is take care of the client code generated for you. And we don't need to worry about whether the channel is going to disconnect, because it's automatically reconnect itself if it's disconnect. I'm going to talk about a bit more of how a good thing about the channel and the services, and we can do some of the advanced things would be otherwise quite hard if you do it in the normal JSON services. But for now, let's just run it to prove it's actually running. I guess we don't need this threading channel thing. There you go. There is the server is still running. Where's our client code? Oh, okay, it's running the server, but not running the client. Let's just invoking it from here. Or we can have a do startup. That's okay. Both of them. Okay. CD client .net 1. What's going on? Oh, there's calling service. I guess I'll get the server address long. That was the long address that we're using. So our new server address is here. Sorry, it's in the. It should be 77335, not 37. So we can stop that one and just start running again. There you go. It's coming up. Say hello. So if we look at the logging from the service, oh wait, we didn't enable logging, that's okay. So this is how easy it is actually having a .NET client code, because all we need to do is reference the protocol, generate the client, just invoke and call the client straight away from there. Ooh, let's see, what's the next thing we're going to do? Okay, we already done that. Okay, since we're doing the client, I'm going to talk about what we can do with the client. One of the good things about this implementation is we can actually implement something really cool with the gRPC channel options. Here's the code. I'm going to do this thing. Not channel options, sorry. The method config. Let's just do that here. I'm going to do. Am I doing the right thing? So let's do this. So in this method call, I'm going to say having a method config with name default, and we are going to have a retry policy. What that means is we're going to have, say, if the service become unavailable, that's the condition, the retriable status code, we're going to try it again until it reach either max attempt or max backup time. So what we're going to do is, to prove that, we're going to have a server running side by side, and we're going to stop the server. So we're going to stop the services, and just having the client side running all the time. And then we see how it's actually be able to retry and be able to sustain itself with not much code that we used to write. If you implement this manually, there's a whole lot of troubles that we need to go through. There's retry policy. I think what we need to do is to be able to have that method config in the channel. So we're going to have next to the channel. Oh, there is. Okay. Now we have the channel config with policy. Now I'm going to, let's just go into have the server here. Going to spin up server here. .NET 1. At the same time, for our client, oh gosh, I want it to actually constantly calling, second kind of arrangement here, while true, just to prove that we're going to have something like this. And you can have it wait for maybe just a second. All right. So we're going to have it running. Oh, got it long every time. Let's just start with this, actually. It should be quite convenient. Set a startup project. All right. Here's our client, and there's our server. So if I stop the server, it's going to be trying that, and but it's not dying. It's not giving an exception because it's keeping trying. If I run the server again, you keep going. So that's the great thing. So if you have, let's say, a server, it's upgrading or somehow you have restarting itself, you will still have very robust, having a reliable kind of client to be able to reconnect, to be and just keep going by itself. Cool. Let's see what's the next thing to do. The next of the kind of cool thing is the cancellation. I haven't done a cancellation code. I have nowhere to cheat, but I'm trying to get the cancellation. So what it means that if the server takes forever to do things and the client doesn't want to wait that, I can just cancel that thing. It doesn't seem to be very exciting, but it's very useful. Things that if you actually running a query, a SQL query, that's very expensive, and then the client or whoever doing it decided I'm not going to run this query anymore, I'm going to do a different one. You can actually cancel that query by saying the cancellation token propagated from the client to your server, goes to your database services, say cancel that query. I'm going to run a new one. In the normal kind of scenario, that we're going to take, like it's going to wait for this, the SQL server going to very busy, and you have to wait for that query to be finished until you can send a new one. Let me just try if we can get that running. So assuming, let's say our server is quite a long one, expensive one to run the service and take forever. Let's say it's going to take 10 seconds. Let's just do a bit longer. Let's say 20 seconds, just in case we can't demo that. You okay? Oh, we don't need that anymore. Sorry. So that's demoing that we can actually cancel this and send a new one along the way. It is not actually. I'm going to do, we just prove that we can receive the cancellation token. We're going to spin it up and keep going. We're going to set breakpoint to prove that there's a cancellation token coming in, and then we can actually cancel on something. So let's just do something like this. Okay. Let's say this one's never finished and keep going forever. And so, let's give a warning. Does it build? Yes, it does. No. Because we need to stop this service here. All right, it's built. That's okay. So if context, that's good thing about context is that we get to access a lot of things that in a normal ASP.NET Web API kind of scenario, you have to actually get HTTP context or all sorts of kind of thing. But because of this here, the gRPC services actually, so alongside your normal object you're going to pass in requests, you have additional context to be able to have a lot of other things that you usually have. I believe the cancellation token is here, yes. Yep, so we can do things like debug. Dot attach. Or debugger. Dot break. Okay, so we're going to have a server running, and hopefully that server is going to go forever because it's never finish. And we'll be like this in a debug kind of mode. At the meantime, we're going to have the client code to call it. We don't do while true now this time. We know that this is going to be forever to finish. So what we're going to do is when we call that, we send a cancellation token. New, we should be able to have a cancellation token passing here. Core options. Was it? Oh, create cancellation token source, yeah. New token source. Equals new cancellation token source. Yep. I'm just working out what's the parameters we're going to pass in the cancellation token. Where's F11? Gosh, could that be F11? So obviously, probably the core options. Inside the core options, yes, we have a cancellation token there. So let's just do that. Core options, we're gonna have passed in, new core options. Cancellation token. Not sure how to get it work. I guess we can have a core option here. It's going to give us the cancellation token. Core option equals new core options. And then we can pass this core options into here. And then we can let it go. So by default, this should never get out. It should go forever. Yep. Which is expected. We should be able to put the breakpoint here and knows that it actually goes forever. There it is. It goes forever now. So cool. Now let's stop this client. Let's just hopefully. As you notice that when we stop the client, it actually send the cancellation token. That's the default behavior, of course. But we can actually stop it programmably. Let's say we're going to say spinning up a task, a separate process to do cancellation in maybe a few seconds. Task.run. going to be start. Okay, in here start.run, we're going to do token source dot cancellation token. I don't know, where is the cancellation token is? Token equals call option dot cancellation token. There is. So hopefully, if we cancel that cancellation token, how do you cancel that? Oh.
From the source. So call options needs cancellation token colon token source dot cancellation in the constructor of call options.
Oh, we can pass in a cancellation token here. Oh yeah, let's of course. Thanks for that. Token source dot cancellation token dot token. There you go. Now we can have token source. We should be able to cancel that here. Cancel. There you go. Let's just do a wait a bit here. Process. I'm going to do a wait. How do you do wait? Not process, sorry. Straight, thanks. So sleep. That's the 2 seconds. And then we just cancel it in after 2 seconds. So.
Line 46.
Oh, that'll be too soon. Okay. There you go. So we're going to run this. We're going to spin up the server, and we can hopefully invoke it from our code somewhere. All right. We're going to spin up the server to ensure that it's running, and then we're going to, so it's going to break anyway in 2 seconds. So let's see. We're going to run that. We should be able to see core service. Oh. Start may not be cool. It's already started. Am I doing it wrong? I should be able to just do task and run, isn't it? Let's just do like this. It's going to start anyway straight away. So let's start the server. And then run a client. Hopefully in 2 seconds, we're going to see the breakpoint. There you go. It's got cancelled. So this is how easy you can do such a thing. I know you can do it through the RESTful JSON services, but you're going to have a lot more kind of control and a lot more kind of code to be able to do this. But this just give us this kind of thing out of box, which is super duper convenient. Right? I guess that's thing. The next thing, what are we going to do next thing? Python. So one of the beauty of the gRPC, because it's using the protofile as the kind of definition, is that you'll be able to take a protofile using the proto-C tool to be able to generate a client for each of different kind of languages. All those normal languages, or not normal, just mainstream languages, all have the client generations. So it'll be super convenient. So if you're developing a services that you know you want to use gRPC and you know that You got a different kind of client or different kind of people that will using different language to interacting with that services. What you need to do is having a protocol somewhere and take that protocol, generate each of the client for different languages, and then just giving to the people to start using straight away. Another good thing about it, I guess, is if you define the services straight away, you don't need to have your server ready to be able to give it to your client, to give it to the people that are doing the client development, to be able to start their development straight away by using the client generated, by using the service contract that predefined even before the server is available. So just to do that, we're going to, let's say we're going to have the Python client. To be able to do such a thing, I'm going to do VS Code, hopefully. So we're going to create a new folder. So .net.python client. So I'm going to have just client Python code straight away. But before we do that, we need to generate the client code. So with the Python, the client generations, I'm going to go back to cheat again, is to be able to do the client generations, we need to do with the Python, with other languages. C# give us out-of-box, but under the hook, it's called Proto-C tool, which has come from the Google. And Microsoft obviously have quite a heavy contribution on that side. With the Python, we need to use the gRPC-2.proto-C, which is a bit special for Python, but that's okay. I'll cheat by copy this file and take that into our place. Hopefully it can run. I'm going to tidy up the path. So we're not going to copy the proto file. We're going to remain that in the single place, but we're going to tidy up the file. So we're going to generate the client from this folder. So I actually write this piece of Python generation script using what do you call OpenAI thing? ChatGPT. Sorry. Yeah, I'll cheat always. So under the hook, it's actually calling Proto-C with the directory as Python out kind of parameter and gRPC Python out. I'm going to see where it actually runs. It'll be embarrassing if it's not running. Let's do Python generate. Okay. So the tooling, I have a piece of code to make sure this tooling get installed. Let's just copy that and cheat again. Let's just copy all this to have it ready. So I have a Python code called install Proto-C. This comes from the ChatGPT as well. So it tells me what to do. I guess that's pretty easy. And install this is actually for the Java, it's for the web kind of client. I need another one. Do I? I guess I got everything already. This was the one for the Python. I guess we can have it running to see whether it's actually generate code. There you go. Ooh. There you go. The client code generated for us. So there's two code. There's the service with the gRPC.py. This is actually our service stump for the client. This one actually create the service, the server side account code for the Python. I hasn't worked out how to actually just have it to generate the client code only, but I guess that doesn't matter. And the other piece of code, it just something relates to the serialization and deserialization, which we're going to see we can actually call the service. So we have this piece of code called a client. We need to get the port right. We'll also need to copy the certificate. So because it's using the HTTPS, we will actually need the certificate to be able to interacting with it. The reason that we don't need that for the C# client is because it's able to call it and be able to establish the TLS connection through the service call and be able to get the public certificate from there. But obviously the Python code hasn't got that capability, so we need to have the public certificate available for able to, so we can have so we can establish the secure channel with the certificate for the invoking the HTTP call. So that looks that okay now. We can actually have it go to call it. See how it go. We don't need this for now because there's no such a thing really. Yeah, sorry. Certificate is not there.
It's just //
Oh,
//
okay. So I didn't put that. I put it in a loop further before. There you go. Not singing the share. It wasn't belongs to share. It was because it's actually great PB2. Sorry, what did it say? Oh, this one. So it wasn't in the right place before as well. Where is our hello request? I guess we got additional kind of underscore there. That's because this is why it can't actually reference to it. There you go. It's trying to call. But because our server is not up, we just couldn't call it. Let's just spinning up the server. Hopefully, this time it's going to, this is not, oh, this is server, yes. Okay. Is it running? Yes, it does. Oh, what's going on?
It's just still exactly running.
Because our server is super slow, isn't it? Yes, let's just fix that. There you go. We don't need that. sorry. Just comment this out, and let's just run the server from here. And hopefully we can, there you go. So this is how easy we can have a separate client with different languages, and we can call it straight away. It's actually similar, very similar kind of experience. You establish a channel, you create your client. This in the C# in the Python it's called stub, but you just invoke the service with the object that you want to do and give up the response straight away. Super easy. What we're gonna do next? Yep, let's go back to here. So I'm gonna cheat a bit, just copy the code here.
You have a charger?
Charger.
The power icon is concerning.
Oh, that's fine. It's probably not enough power for this laptop. Yeah, weak charging state. That's okay. I'm hoping we can finish that with that. But if we can't, we just finish it. I guess. There's no alternative. It's already late anyway. Let's create a folder. Oh no, that's not what we want. Okay, new folder. Dot. Let's just say ReactJS. Okay. Let's just go to that one. We're going to create the app. Oh, I guess we can do this. Let's do that. Hopefully I'm going to create a thing. I can delete that one now. I don't need that. What's the naming convention? Capital letters. Whatever. Not used to this keyboard. There you go. Because we don't have a capital. Oh, you do. There you go. Come on. Let's have all the naming convention right. There you go. We have one. And we should be able to. So to be able to do that, we need the two kind of singing, the gRPC-Web and the Google protobuf for the serialization and deserialization again. Hopefully that doesn't take a long time. What's the time now? I guess we're going to cheat again, just using the existing one. It will take a long time, go. I guess what I'm gonna do here, I got the web client here. That's already kind of being created. It's a React web app. So to have that, we're gonna have those two packages. As you can see that here. Google protobuf, gRPC-Web. On the top of that, we also need to generate our client code, which are already pre-generated by one of our Python script. called generate.js. Also using ChatGPT to cheat to generate a theme. It doesn't work out of box. I need to tweak it to be able to using the absolute path to be able to generate a client for us. But I guess that's what it is. So we have the client generated, and we have all this code here. And I have a React app. We got an app.js, and in the React app, there's a button. If I click the button, it's going to call the gRPC services, where it's going to create a client with the HTTPS. It work it out the channel for us, of course, and yeah, set the property, do the call. When coming back, we set the response. Set response is here. Use that, and gonna give us the reply message. So let's just see we can. Oh, I think we need to get the 35 as our address, isn't it? Let's see we can run it actually from here. Web client app 1 yarn start. There you go. So another just cool guy again. So hopefully you're going to work. I'm going to send that request. Is our server running? It does. It's kind of error. So what error do we have? We have error says connection refused. The reason it's connection refused is because we haven't enabled the gRPC-Web channel, which by default it won't let you to connect. So to be able to do that, we cheat again to have the web component available. Let's stop that. And after that, we need to inject the service, trying to make it quick. So to have that, we need to add there's a whole lot of code here. Add gRPC-Web. We also need to use routing in this case, so it knows where to goes to. We also need to use calls because we are actually calling it from a different web. Otherwise, it gets blocked. We also need to, in our service, we need to enable the gRPC-Web and then enable the calls. We have the calls policy called allow all, so we need to grab that calls policy too. And there you go. So that's over here. So that should get us going. That should be enough. Let's just run it, see how we go. Okay, it's running. And go back to the web. Ooh, connection diffuse again. Was it? So change it already. 7305. Oh, didn't save it. Oh, yes. Thanks for that. That should do. Let's restart it. Okay, just in case. What's going on? So we should be able to see the network connections here. Incomplete response. Oh, that's because I generated a different kind of code here in this project. We can. Should do. Is the other ones already finished? That's actually copyless. And let's just cheat here again. Is this guy finished? Oh yes, it's finished. Let's actually paste and replace this client code. What did it do? Annoying. Oh, could have changed the other thing. It's inconvenient to have this funny keyboard. So we have this code here. When we install, we need to install the thing. The gRPC-Web. Yarn 8 gRPC-Web. There you go. And Google protobuf. Can we do copy here? Yep. Paste. So we've got gRPC-Web, we've got Google protobuf. What we're missing? We're missing the client code. So we need to go to the generate Python. We're going to have it, not Python, sorry. We're going to generate the JS. Where is our generate JS? Oh no, I need to copy that again, sorry. There you go, the generate JS. There you go. Paste. So this is the same thing that's calling proto-C with parameters. It's quite tricky to get it right, but I can tell you the ChatGPT didn't get it right in the first place. So there's a lot of things I need to do. Yeah. I think we need to get the path right. The path would be on the web. Protos, and I think we call it, this one, the web client. Oh gosh, there's a lot of things. Hopefully, that's going to work. Python. Generates JS. There you go, we got gRPC client. And and we have the apt, we have the dependency install. That should have everything, right? There you go, and yum, stop. Yes, that's okay, because we have thing running in a different pool, this thing. Just close it. Okay, can resolve. I don't know what I did actually. Oh, okay, not under the share.js PB because I was doing that in a different thing. Thank you for that. So it's greet. Dot PB, yep. Is that running now? No. So what's not right? Greeter client, greeter gRPC-Web .pb.js. I thought this should be right. Is this right? Yeah, it's got the greeter client and it's got, hang on, this is not right. Bleed.pb.js. I don't know. I guess you can work it out. You can use your imagination. So this is how it worked. I guarantee it was working. It was working perfectly fine when I was testing it. I don't know. Some of things that doesn't work. I just couldn't actually. All right, let's go to the next one. So yeah, it's actually tell us enable gRPC-Web. So other than just enable the gRPC-Web in the .NET, you can actually having the proxy to be able to proxy you gRPC-Web traffic back to you. I guess the vanilla gRPC services. But if .NET gave it to us, I mean, we can use it straight away. The gRPC JSON transcoding is one of the interesting stuff. Let's just try to get it right this time. It's going to cheat again. What about talk to this one straight away? Because we have it, I have it running. It's probably easier in that way. So with the JSON transcoding, you'll be able to expose your gRPC services through the RESTful JSON services. And as on the top of that, you'll be able to have your normal Swagger or Open API portal. So you can serving your gRPC services alongside another set of services with your normal RESTful JSON services. So the options there. I mean, it doesn't say that if I use gRPC, I can't share my services with this normal traditional JSON kind of arrangement. So to be able to do such a thing, we need to define the annotations. So we would say list services, let's say hello services. We need to import annotations first. That's kind of a reference point. And then we need to have options as a services and have list services under the path of API grid and the name as the parameters. And on the top of that, we need to have the JSON transcoding. And if you want Swagger to be enabled, we need to import a Swagger kind of client. And then back to the program, need to enable the JSON transcoding somewhere. There you go. No, not that one. I'm sure there's a code in the enable JSON transcoding. Line 50. No, not. Yes, this one. There you go. Thanks for that. And once we do that, we need to enable the gRPC Swagger, and we'll be able to generate the Swagger documentations as JSON definition file, isn't it? And then we just use Swagger and use Swagger UI, and having the endpoint is the JSON definition in the endpoint. So it should give us something. And this is running under 7337. So if I start going that one, if I go into our Swagger endpoint, we should be able to having a normal Swagger open API portal. So why do I? Okay, and then we can go into open up this. Let's say we want to test it out. We can say cool. Just like that. And that would give us the normal JSON kind of reply. Yeah. So what's the next thing we're going to cover? I guess we can have the JSON transcoding. The other thing, alternative we can do is having the gateway services to be able to take that gRPC channel and the services and translate into our normal JSON services or RESTful services. And we can have the similar kind of the discovery services that Open API portal through. We can have, I think I used to write a little Go code, the Golang. Having that implementation by default, we can actually having that plugin and have that gateway services running straight away. I'm not going to demo that today because I'm not good Go coder. Next one I'm going to show is the streaming. So one of the great things about the gRPC is support the streaming, the server-side streaming, client-side streaming, or bi-directional streaming. And that means you can open up the channel on the both place and both talking to each other simultaneously. If you're using RESTful services, you would either use socket or use polling or use probably slightly different kind of arrangement. The implementation is quite difficult from there, but one of the good things about this is the implementation about the streaming services is super easy. I'm not going to have it in code. I'm just going to show you what I have here. So I have a document proto file. We're going to give us the document service. I'm going to pretend we have the download big document from server file as a server-side streaming. We just put a stream here, and we're going to have the document list data. So once it's going, once you establish the channel, I guess the service, the core, we can have something in the server keep pushing the message out, and the client will just get it straight away. So to do that, all you need to do is while you override this, you're getting the iServer string writer. With this iServer string writer, you'll be able to write your data in that straight away. So let's say if you do something in the server, it's going to take forever. You want to inform the customer or user the progress of this. In the normal way, you probably use polling, or otherwise you can, if you want to do socket, or you can do that. But in this, you can get this kind of straight away. Everything's super easy, super kind of convenient way. I'm actually not going to call this. Let's see if we can get it working as well. I guess this is. We're going to use this thing. So if we call it from here, what's going on? Yep, that's done it wrong. And you should be able to establish the connection. And then getting that data straight away. This is coming from the same one core, one channel, but everything's pushed down from the string. Similar thing, we can do the two-way bi-directional streaming by establish something like this. You put a string on the server one, the core one, and got a string on the reply one. And when you're doing that, you can have your client code like this. So in the client code, you set up the async duplex streaming core. This is by default, the code generation is done for already. And then while you're doing that, we can. So this is the, so we have the reading code in a different kind of thread, and at the meantime over here we write our client data simultaneously. So this is the way that we can have kind of, I don't know, I mean, there's this, I'm sure there's a use case somewhere we can have a two-way kind of a communication, but this is super convenient and super. The beauty of this is the code generation and the gRPC channel that is going to create it, having all sort of hard stuff. Let's say the connection need to be maintained somehow. If you have the network that it's keep dropping kind of thing, it will keep connection for you, and you don't have to write your own code to implement that yourself. Everything is there for you, and then you pretty much guarantee that what you write is what you're going to get, regardless what kind of network scenario or what kind of thing you're going to get. Yes. Let's just get it right. Okay. Other than that, yep. All right. I'm not going to talk much about it. So you can do mock testing. It's super easy as well. All you do, you can mock the channel. You can mock the behavior of the core. Let's say, I'm mocking if I have the bad network kind of thing. It's all doable in this kind of scenario. And not only you can do mock on the server, the code generation for the client code is also optimized for the mocking testing as well. You can do middleware, let's say the middleware for logging, for the metrics, authentication, and more. Yes. The next one is the changings, versioning. Another good thing of the versioning of the gRPC is, let's say I have the service like this, and I have the message like this. I say hello request, but I think my name is not very good. I just change it to full name. But after that change, what the beauty of things, the client code does not need to be updated, because what transmitted over the generated code, not generated code, the serialized data is the number. It's the slot 1 have this data, slot 2 have that data. So the client code can still maintain the same thing, although this is called name, not full name, it still be able to interacting with the original gRPC services, the updated gRPC services with the original client code. So this kind of change in the proto change, we call it non-breaking changes. So as long as you maintain the code and do non-breaking changes, you can have same kind of services with the old version of the client. Of course, if you have breaking changes, let's say you change the number here, or you remove a field, that field is no longer exists, that's a breaking change. You might introduce the versioning or a different kind of things that where you usually have your JSON arrangement. To conclude that, so yeah, I guess we can all read. The development contract is pretty fine. It's very easy to manage. Very efficient binary serialization. The data transfer over the network will be a lot less than the JSON or the other kind, let's say XML, whoever did the WCF SOAP web services before. The code generation is generated as long as you have protofile. You don't need to wait for the server to be ready. The streaming and all this heavy lifting that already done for you with the deadline, cancellation, timeout, those kind of things that are for you already. That's it. Questions? Yep.
So with the timeouts and the retries,
Yep.
does that integrate with poly.NET policies?
I'm not familiar with that.
Behind the scenes?
So just repeat the question.
Poly.
So is the question that does it interoperate with Poly, or yeah? Does it need to use Poly, or?
I'm not sure what's the poly. I guess, is it the ASP.NET feature?
Yeah.
Yes, I guess it's probably not, because what happened with gRPC is once it's established the connection, the channel, everything's happened within the channel itself. Maybe in the first connection, it may use that kind of thing, but what afterwards? Yeah, I'm not sure. Can't answer that. Yeah. Sorry. That's all?
Had a question online from Zoeb. I'm not sure I pronounced his name correctly. I apologise for that. Who's new to gRPC? He's just trying to figure out what is the difference between gRPC and REST. Is it the binary transmission of data, or is that the main difference, or?
Yeah, I think this pretty much gives us everything. The protofile, that's pretty fun. I guess it's not gRPC. If we only talk about gRPC, it's the transmission protocol or transmission, what do you call it? I don't know. It is different. It's a binary format by default. Yeah, the gRPC-Web is a binary format too. But you can actually enable the text format, which is the base64 formatted binary. And if you take that base64 formatted binary, you can actually put a little website somewhere to decode it for me. You can see the slot 1 with this data, slot 2 with that data, but you can't work it out which one's what, because there's no protofile in with that one. Protobuf is different. It's the it's the serialization, deserialization technology. I think Dom actually mentioned you can actually having the GraphQL message transmitted over the gRPC protocol.
I think John.
Or John, which is quite cool, I think. I don't know that before. Yeah. Yep. Yep.
Thank you. I think the gRPC looks different to me from the traditional HTTP requester types like GET, POST, or POST delete. So how do we align this gRPC with those traditional ways?
I guess,
Totally not.
yeah, no, you can't because
I'll just repeat the question for those
yeah.
online. So, it's
So
really,
in a RESTful service, you have GET, PUT, or options. This all kind of a header in your header. No, you can't because gRPC is very kind of it's the action and the data. That's all we care about. If you want to have the GET or the PUT, you can just put having a PUT method, PUT action, and the data with the PUT input. Yep. Cool.
cool. All right, well, would you thank Andy for his presentation?
Thank you.